I've been reading the dictionary. I do that some evenings. As we talk about the operon, I think it's important to use our friend the dictionary and make sure that we understand some of the terms associated with the operon. An understanding of some of these words will help us as we go through it. Let's see what we have in the dictionary here. We'll go to the operon itself and see if what it says here. So operon, OP. I'm sure it's in here. I've looked before, you know. Oh, here we are. Operon. Operon. Ah, there it is. The operon, it's a cluster of genes under the control of a single promoter. That's what an operon is. And those cluster of genes are generally related to one another. So let's talk about the other things, the other words that we want you to know. First one that we want to talk about is a promoter. What is a promoter? Not that kind of promoter. No. The promoter that we're talking about is a sequence of DNA bases found on the DNA, obviously, that the RNA polymerase will bind to. And that sequence of DNA bases, the RNA polymerase will bind to, and it's going to be transcription will occur after the RNA polymerase binds. That's the promoter. Promoters can be strong or weak, and that will play a role in how the operon is regulated. And so that's a very, very important part of the operon. Another sequence of bases that's very important is called the operator. So what is an operator? No, that's not really the operator that we're thinking of. And that certainly is not the kind of operator that we're thinking of either. Oh dear, no. The kind of operator that we're thinking of is also a sequence of DNA bases. Oftentimes, the sequence of DNA bases is located downstream of the promoter, but not always. And it's to this sequence of bases that an effector molecule will often bind to and will determine when a promoter, the RNA polymerase that is bound to the promoter, will transcribe the structural genes. Okay? So we have the promoter and the operator. And these two DNA sequences, in effect, will work together to determine when the structural genes are transcribed. It's a wonderful thing. Now these things, working together, the transcription of our structural genes, this is how we regulate operons. Regulated operons can be under positive or negative control. And these regulated operons under positive or negative control, what determines this is based upon the effector molecule. If the effector molecule is a repressor molecule, then it's under negative control. If the effector molecule is a activator, then it's under positive control. And that's it. It's a very, very simple thing. Simple, simple, simple definitions. Both positively and negatively controlled operons can each be both repressible and inducible. And again, these are two words that are probably found in the dictionary. Let's look them up. Repressible. Repressible. To put down. To shut down. To turn off. Okay, so if something has been turned off, by inference, that means it is on to begin with. Okay, so a repressible operon then would be an operon that is already on. So if you have an operon that is repressible, by definition it is already on. That operon that is already on could be under positive or negative control. And that doesn't matter when you think about a repressible operon. The only thing that matters when you're thinking about a repressible operon, just think about that term, repressible. What that means is that the operon is on. And whatever that molecule is that's going to be using it, it means it has the ability to be turned off. Okay? So that's what a repressible operon is all about. Let's look up inducible, shall we? Here we go. Induce. To lead. To bring on. There we go. To draw. To infer. To turn on. There we go. So, by inference then, if we are turning something on, then it means, by inference, then its initially, it must have been off to begin with. So in inducible operons, these are operons that are normally found in the off position. They are not being transcribed. But something happens and they are turned on. Okay? And once again, inducible operons can be under positive or negative control. Alright? So the state of the activator may be active or inactive. And that's going to depend on the type of operon that it is. But if it is inducible, its normal state is off. But when it is induced, it is turned on. Okay? So when we're talking about a repressible operon, it is already on, but the repressible operon is an operon that will be turned off. And when we are talking about an inducible operon, it's an operon whose normal state is going to be off, but it has the ability to be turned on. Okay? And keeping in mind the definitions of these words, what it is to induce something and what it is to repress something, will really help you in being able to just remember rather than just trying to memorize what it is about operons. This will really help you in understanding operons. Well, I hope our little dictionary lesson has helped us. And so please welcome to A Night at the Operon.